in a series on ratio and proportion calculations. In this video we will discuss how ratio and proportion calculations are written up. We have here two rectangles that are similar. Actually these are similar. They are not congruent. They don't have the same size, but they do have the same shape. On this shorter rectangle, this is 5 squares for its shorter side and 10 squares on it along its longer side, and this bigger one here is 15 units on the shorter side and 30 units long along its longer side. We are gonna make equivalent fraction looking cluster of numbers in different combinations. To write up ratio and proportion, you can write it this way. 5 is the short side on the small square, is proportionate to the 15, the short side on the big square, and the 10, the long side on the short square, is also proportionate to the long side on the big square. Say, to put it in letters, maybe it's visual. Here is the short side on the first square and the long side for the first square, so that's S1 and L1, and this is short side on the second square and long side on the second square, S2 and L2. So far I wrote that the L5 amount, this one here, the short side on the small square, and I put it down there to be the numerator in the first one, so that's the short side on the smaller square, is proportionate to the short side to the second square, to the bigger square, and the long side on the first shape is proportionate to the long side on the second shape. I don't know if it makes more sense to you with letters or numbers, but particularly with letters you can see how the short and short, long and long are stacked vertically, and the 1 2 and the 1 2, or horizontally it's 1 1 and 2 2. How the pattern is being built here. Another way to write up this one is, like I said, it is possible to do a vertical flip. The 15 is also proportionate to the 5. The long side, the short side on the big square is also proportionate to the short side on the small square, just as the long side on the big square is proportionate to the long side on the small square. And just to make sure that the amounts are indeed equal, let's do a calculation quickly. 15 divided by 3 equals 3. 30 divided by 10 is also 3. So the amounts are equal, and the equality on both sides of the equal sign are true. With this format, because it was just a vertical flip, the short side length on the second square goes up in the first numerator, and the short side length on the first square goes into the denominator, and likewise that's also flipped. You can see how it's being built. Another possible combination that we discussed in the previous video titled Solving Ratio and Proportion, I mentioned that we can do a flip this way with the amount. Let's do that one. If it's possible, then the fraction is 5 over 10 equaling 15 over 30. Is the equation still true? 5 over 10 is 0.5 and 15 over 30 is also 0.5. You can check it on a calculator. It still works. Now let me visualize where the short and long sides go with this one. When we did a flip this way, 5 is the short side in the first square and 10 is the long side in the first square, and is proportionate to the 15 is the short side in the big square, the second shape, and is proportionate to the long side of the second shape. And likewise, it is possible to do a vertical flip on it, and we can write 10 over 5 equaling 30 over 15. Let's calculate the value of this one. 10 over 5, 2. 30 divided by 15, also 2. So the numbers still check out in this combination. The 4 independent values still maintain equality, and in this format they are: the 10 is the long side of the first shape, and the 5 amount is the short side on the first shape, and the 30 is the long side on the second shape, and this is the short side of the second shape. You can see here is all 4 combinations in which ratio and proportion can be written up, and as you write it, you can say the short side on the first shape is proportionate to the short side on the big shape, just as the long side on the short shape is proportionate to the long side on the big shape. And I was reading this one. If I wanted to go with this one, which is also true and also works, the short side on the first one being proportionate to the long side of the first one. Well, that doesn't quite work with logic, because this short side has not a lot to do with that short side. This short side is similar to the big shape's short side, but in terms of mathematics, this also works just as well if you compare this one to this one and this one to this one. Now 4 combinations I'm going to write up that do not work, and this is how the combinations look like. Whatever you do, you cannot compare the short side with the long side, and at the same time comparing the long side with the short side. Let me just write it up in terms of letters. The 5 is the short side on the first shape, and 10 is the long side on the first shape. So far so good. So far this is the same as that, but the second part is flipped over. This is a flip that isn't done on a diagonal. This is a flip that's done not on both at the same time, only on one of the fractions. On this one I flipped the 30 is the long side on the second shape, and the long side on the first, 15 is the short side on the big shape. Another combination that also doesn't work. Let's calculate. 5 over 10 is 0.5, and 30 divided by 15 is 2, and 0.5 is not 2. Another combination that doesn't work, just bear with me, there's gonna be 4 of them that don't work and 4 of them that work. However, they will all be useful, and I'll tell you how in just a minute. We can do a vertical flip on this one, standard procedure. We have 10 over 5, and it will not work with 15 over 30, because now 10 over 5 is the amount that is 2, and 15 over 30 is the amount that's half, and they don't agree. And what happened is that the wrong color, that the long side on the first shape got to the top and the short side on the first shape got to the bottom. And on this one, the 15 is the short side on the second shape and the long side on the second shape. There. Another combination that also doesn't work is 15 over 10, and it will not work with 30 over 5. 15 over 10 equals 1.5, and 30 divided by 5, I don't know, some super small, 30 divided by 5 is, oh yeah, 6, sorry, my bad. 1.5 here and 6 there, and they obviously are not equal. In this combination, 15 up top there is the short side on the bigger rectangle, and 10 is the long side on the first shape, and 30 is the long side on the second shape, and 5 is the short side on the first shape. And we can do a vertical flip on it, 10 over 15 and 5 over 30. And let's see this combination here. 10 is the long side on the first one, and 15 is the short side on the big one. 5 is the short side on the first one, and 30 is the long side on the second shape. Alright, I'm gonna draw a line here. All of these consistently are unequal, and all of these formats are consistently equal. All of these formats, or any of these formats, are useful in, sorry guys, in direct proportions. Calculating direct proportions. And all of these formats are useful in calculating indirect proportions. And I know that the equality is not preserved in either of these, but they will be used exactly as is. Now, how can you tell if your format is a direct format or an indirect format? There's a pattern to this madness. Look at this one here. Short side, short side, short side, short side. The short and short are vertically lined up like this, or the short and short are horizontally lined up like here and like here. Also, what is horizontally lined up here is the 1 and the 1, the 2 and the 2, 1 and the 1, 2 and the 2. And in this one, the 1 and the 1 are lined up vertically with the 2 and the 2, 1 and the 1 vertically lined up, and 2 and the 2 vertically lined up. In these examples here, vertically or horizontally, you don't have the same letters. The letter S's can be found on a diagonal consistently. Same here, and same here. The S's are found on a diagonal. so are the L's found on a diagonal. The L's are on a diagonal here, on a diagonal here as well, and on a diagonal here as well. Also notice that whereas the 1s and 2s read vertically here and horizontally here, 1 1 horizontally, in these ones, the 1s and 2s also read vertically nicely or horizontally nicely. So you can't really go with the 1s or the 2s. You have to look at the letters where the amounts are actually written. In a direct proportion again, the similar amounts are either stacked vertically or horizontally, and in indirect proportion the similar amounts can be found across each other on a diagonal. That's what makes the difference between the forms. Direct proportions can be written up and indirect proportions can be written up. So that concludes this video. I hope you are not dyslexic with this. We're gonna get to calculations in the next video.